Hi everyone and welcome to Rage Print. This is Andy and this is the start of another build series where we're going to be building the Vonjet Hamster BB8 sphere. This is in the beta group which I'm lucky enough to be part of. So I've been spending the autumn winter printing out all the pieces. They're now ready to go. I've also got hold of all the mechanical components I need to bolt the thing together. I'm also going to be printing a lightweight PLA BB8 dome using the A&P design and using the halo head mechanism to attach the dome to the body. As I said, all the parts have arrived, all the pieces are printed. I will briefly go over how I set up the prints, and then it's just a case of bolting the thing together, sanding, printing, priming, the usual. I will not be going over the drive. I have a drive that's based upon the Dave Alvarez hamster drive. There's not really anything I can say to that because I covered it all in the BB8 Builders intro in Droid Builders UK last August, which is linked to on this video, the Droid Builders UK website as well, and the Droid Builders UK YouTube channel. As I said, there's not much more I can say to that one. We did talk about the Vonjet Hamster as it's up and coming, and this is now the build series to cover that. So why don't you join me where we start to build BB8. So here we are in Cura. I've loaded up one of the triangles for the artillery sidewinder. I'll go over my print centers in a second, but as you can see it fits nicely onto the print bed. You can see I put support blockers in here. Even though it comes with its own pre-built supports as part of the file, there are no supports there, which means when it tries to print, this bit becomes quite stringy and actually weakens. So if I put in supports here, by turning supports on and putting supports here, that becomes nice and strong, and then it can continue using these supports, and then the support blockers stop Cura generating extra supports. Simplify may have other ways of doing it, but I don't know Simplify. So here's our triangle. So I'm doing a 0.2 layer height, with the initial layer height 0.2, line width 0.4. I'm doing 3 walls, 4 top and bottom layers with a line for the pattern. And there we go, just go down a bit more. I'm trying to hide the seam, doesn't always work. Infill density of only 30% using triangles, so it's going to be quite strong. And printer temperature, this is just based upon the fact of where I am printing and the time I was printing. It was the middle of summer, quite humid. So these values will change depending upon what time of year I'm printing, although it is getting better in here for that effect. I'm only printing at 50mm a second. Again, that was due to the material and the conditions I was printing in. Retractions on, retraction speed, again that's down to material. The Z hop when retracted, I found that was quite useful, otherwise it tends to knock over the triangle the far higher up it gets. As you see, I've got supports on, touch and build plate, 70 degrees overhang, probably can make it a bit lower because at the end of the day you only need supports here, and grid, that's what it really needs. I haven't turned on adaptive layering because bizarrely it actually makes the print longer. So just do a quick slice, and there we go. So you get 1 day, 12 hours, 53 minutes for one triangle. Probably could be printed a little faster. As I said, depends on the environment you're trying to print in and the material you're trying to print with. I'm using Ice Filaments PLA. They call it PLA Plus. As there's no standard for PLA Plus, it's hard to tell what PLA Plus actually is. But so if we just zoom around here, so you can see I've got brim on. The support blockers stop the support appearing here. But if we just zoom back in here, you can see it has now generated the support layer under there, which will help that print much better and much stronger. So that gets sent to the printer and print that off 6 times. The other triangle is pretty much identical apart from the fact there are some vent lines, and I think it's on this axis here. There's 3 vent lines there, and you print 2 of those. Other than that, the triangle's identical. So, right, as you can see here, I've now loaded circle 4T into Cura. Again, it just about fits on a Sidewinder print bed. Something I forgot to mention when I was doing the triangles, I did actually print some of the triangles on the ender. Again, it fits. I had to turn the brim off in that case for it to fit. But it did print fine. Pretty much identical settings in terms of infill, walls, top and bottom layers, that sort of thing. But back to the circle. So here you go. You can see the circles on there. You have to nudge it a bit to get it to fit, but it will fit. And in this case, you do have to turn. So this is the circles one I've got. Again, it's a 0.2. I'm only doing 25% infill on this one. So again, there's support going on there. So let's go back to the top. Yeah, 25% infill. And that's mainly because it's a bigger piece. It doesn't. There's more structure for it to support. It doesn't need quite as much going on with it. So there we go. 3 wall lines, 4 layers, a 0.2 layer line again. And then, sorry, I just skimmed past it. So supports on and no build adhesion, because otherwise the the adhesion layer is too big to go around here. So we just slice this. Right, so here we go, it's finished slicing, and we're now at 2 days, 15 hours and 1 minute using 500 grams. The circles are long prints, and most of that is actually the support that sits underneath. You can print the circles without supports, but with the hamster you need the supports because you need the smoother underside. It doesn't matter how much sanding and filling you do, you'll never get away from the fact that if you haven't used supports, that underside is going to be quite stringy. In an axle drive, it is less of a problem because nothing's rolling on it. It's just floating above it. Yeah, so that was 2 days, 15 hours. So let's look at the preview on that. So there we go. As you can see, if we start working our way back through the build, here we go. So you can see the infill here. I mean, the difference between 25 and 30% isn't going to be that much, really. I could have printed the triangles at 30% in all honesty. As I said, because this is beta, there are no default print settings. It's kind of like try it out, see what works. I've picked my print settings based upon what some of the others in the group have chosen and used and had results with, because they can print it faster than I can. And that's what they've chosen. May find you come to put the drive in the ball and it's not good enough. You have to reprint the circles again, but we'll see. So you can see here, we've got the infill, and then this is the support material that's gradually being printed up. And you can see it eventually joins the circle and then follows on with it all the way to the top. That is a pain in the neck to remove afterwards, but it is needed. If you look at it underneath, it is needed. I mean, here it's fine, it doesn't need the support, but when it gets to this point, it starts to become too stringy without that support. But that's what adds a lot of the time on. So yeah, that will get sent to the printer, and there's one for each of these circles. 2 of the circles have the hatches in, which I will load up in a second. And then, yeah, send them off to the printer, print them out, and then hopefully you've got some nice prints to use. So here you can see is the hatch. It's basically just another circle with the insides cut out. So if we zoom in, we can see here that these bits would be the orange part on the BB8 ring, but you can see they've been indented, and this is to give something for the circle, the actual hatch panel itself, to sit on and screw through into. The orange part of that circle is actually part of the hatch, which I'll show again in a second. Other than that, this prints identically to the circles. it only needs supports here, really. So it prints a lot faster, as we'll see. Alright, so here you go, 1 day, 3 hours, so it's half the time of doing the full circle, which kind of implies that the other half of the circle, the other half of this hatch, is going to be the other half the printing time. But I'll open one up and I'll show you now. So here we go, this is the hatch part. As you can see here, these are the orange parts of what would be the normal part, the orange ring. And then if we just spin around, you can see it's very slightly fluted to then sit nicely into the ring. And then there's the notch which follows under there for to sit on top of the ring itself. I'll just sort of show under here, so you can see those notches there. The red areas is where it's going to generate support. There we go, so 1 day at 11 hours 43 minutes. You add the two together, you get into roughly the 2 days 15 hours. Most of the time is actually spent doing this section, and again the supports that go underneath it. Here we go, we've gone preview mode, and if we just cut away the layers, you can see again it prints exactly the same as the rest of the other circles. It creates a support layer, but as you can see in this case the support layer seems to start further out even though it's a smaller piece. So it's exactly the same, and it starts creeping up and then reattaches. And again, this is a pain to remove, but a necessary pain. And these holes here are for the lights. At the moment they're just a direct copy of the Vonjet V3 ones, which actually have the lights installed as a circuit all the way around the body. Not really possible with the hamster drive because of the fact you then have the ball rolling on top of the wiring and the LEDs potentially crushing it. There may be a way to inset them, but then you still got to find a way to put the wiring around without it getting caught within the drive. What somebody has done is designed just a resin lens that sits in there, and then you put a lot of LED lights around the drive itself, so it basically turns into a massive light bulb, and the lights then come through these resin lenses which are tinted to the right colours. But yeah, so again that gets sent off to the printer, printed, and then in 1 day 11 hours and 43 minutes, if you can believe Cura's timing, you'll have your printed part. Okay, so you've spent weeks printing out all your parts, you've had a few failures on the way, it's inevitable, it's printing, and you end up with these. So these are the circles that we said take about 2 days to print. I've removed the support from the inside. As you can see, it's a lot smoother than it would be if it was just printing without support. And if I lift these up carefully, they're balanced on my desk. We have 4 of those. And 4 of those. And we have the hatch panel. This is literally just come off the printer. I haven't even bothered cleaning them yet, but apart from taking the supports off, there are supports here. So that's those taken off. That's those. And then we have the hatch itself, and then the hatch sits in like that, and then that will be your access in to get to the drive, do what you need to do. And as you can see here, it slots very nicely in. And as I said before, there's 2 of those. So just get those out of the way. And then we come to the triangles. So you can see there's the triangles. They were printed in, he says, looking at them, that orientation. And you can see where it's going to do it. You can see where needing the support was necessary to give this a nice clean edge. Otherwise you'd have nothing for the screws to bind into. But they're in, and you can see those are ready for the Vonka bars that we'll talk about in a second. And we have 8 of those. So you spent ages printing all of those, and you're ready to go. What else do you need? Well, as I said, this is based on the Vonjet V3 for the axle drive. So you need a friendly American builder to send you some parts, because they are only accessible from a MasterCar, which does not ship outside of the continental US. There are other builders who have tried sourcing parts from AliExpress, eBay, with varying amounts of success. And the main bit you actually need from a MasterCar are, get some, those heating sets. And it's not the size, it's not the diameter of the heating set that's the problem, it's the height. And they're only accessible, they're only available from a MasterCard, this particular height, and nobody's been able to find them anywhere else outside the US that I know about. So as I said, you need a friendly American builder to send you the parts, including the carbon rod, and then you're almost ready to go. You also need, as I mentioned a few minutes ago, Vonka bars, and that's a Vonka bar. It's a machined piece of aluminium with 4 holes in it, and they slot into the triangle like so. You can see the holes here, so they would line up, and then the other triangle connects like that and gives it a nice, there's one each side there, gives it a nice rigid connection. Now, there are instructions in the Vonjet build guide on how to make these yourself from a strip of aluminium. There's a 3D printed jig that you can do. Got one here. And you can just sort of catch it with the light that there are 4 holes that line up there. So where you, because I haven't quite lined it up properly, that line up where you put the holes in. And then you drill it through with a pillar drill. I didn't do that. I have a family member who owns a machine shop, and very kindly they cut these out for me. So I didn't feel like cutting out 24 exactly the same and knowing I'd get one wrong. So I said, family member cut those out for me. That's very kind of them. And that's ready to go. So that's all the pieces you need to build the Vonjet sphere itself. Other than that, you need a need the dome, and I'll just disappear and go get that. So what you need is the dome, and here we have a A&P dome. Now you may notice there's a lot of stringing on here. That's because the white is lightweight PLA. This thing's incredibly light. The black is normal PLA, just to give it a bit of structure, a bit of support. John printed this. See, the inside is very stringy, and that's just the nature of lightweight PLA and retraction. As I said, that is really light. And we've got this is come off the printer yesterday. The lid, and like the spheres, you've got the support there. It needs to be removed. That's going to be a pain to remove. A one-piece skirt, which, as we know, sits like that. The microphone. And then the other remaining pieces being the radar surrounds and the holo projector and PSI. So that's it for now. We have all the pieces, bar the magnets, and we're ready to go. So the next step will be cleaning up the prints enough that I can put the sphere together and put the Vonka bars in. And then we'll put the heat insets in. At that point we can put the sphere together. We can then look at sanding it and priming it and everything so it's all nice and smooth, and we'll sand it all in one go with an orbital sander so it keeps a consistent sanding all the way around. We'll take it back apart, paint it properly, and then put it back together with the drive-in. Likewise with the head, we'll clean it up, paint it, and attach the head mechanism. The drive that I'm currently using does already have a head mechanism. It's using Carey's head mechanism. That's going to be taken out and replaced with the Halo one. and that is literally just a kit for the drive itself. It's just a case of taking the carry version of this off and putting this one on. So that's it for now. Thank you very much for watching. There's a lot to do, and hopefully by the end of it we'll have a rolling working BB8. As I said, thank you for watching. We'll see you again soon. Bye.